7b asks us to take a look at where we started in 7a with the equation for NH3 as a gas plus 5O2 as a gas, which is in equilibrium with 4NO gas plus 6H2O, also in the gaseous form. Now what we want to do in part B is to figure out what the Kc value is, which is the equilibrium constant. And then it also asks us to look for the units that we would have. So what we do is we put the products on top and the reactants on the bottom, as we normally consider products and reactants. Again, we're in equilibrium, so we do have the forward and the reverse reaction occurring, so we could talk about these are the reactants if we wanted to, but standard practice, if it's on the right, we consider it a product. So our products are going to go on the top, and we want the concentrations. So I'm going to have the concentration of NO raised to the power of its coefficient. So its coefficient is 4. I'll raise the concentration of N to the power of 4. And then I'm going to multiply that by the concentration of water in its gaseous form raised to the power of its coefficient, which is 6. So concentration H2O raised to a 6. That entire thing will be divided by my reactants, and I have NH3 with a coefficient of 4, so I can write concentration NH3 raised to the power of 4, and I have O2 with a coefficient of 5, so it will be O2 concentration raised to the power of 5. Now this problem didn't give us any concentrations that we could actually work with, so we're not going to have to worry about calculating anything here. This is sufficient for what the first part of the question is asking. The second part of part B asks you what the unit would be, and it's going to be moles over liters because we're dealing with concentrations. And we have 4 and 4, 6 and 5. They all cancel out. I'm left with 1 mole over liter. This mole over liter could also be written moles to the liters 1, -1. That's saying the same thing. It's putting it on the bottom of the fraction. Or I could write out moles over decimeters cubed because 1 liter is equal to 1 decimeter cubed. And using the same logic from here to here, I could say that I also have moles times decimeters to the -3. All 4 of those are acceptable answers for the units that would occur. And again, it's because each of these concentrations, moles over liters, this one's raised to the power of 4, this mole over liters is raised to the power of 6, moles over liters raised to the power of 4, and moles over liters raised to the power of 5. Everything cancels out except for 1 mole over liter. That will not always be the case, but in this instance it is.